one's chips?
Yes. So at least in the beginning, we can obviously launch the chips that are already being made. So our current reference design is for Nvidia Rubin chips, or it could be either GB300 or Rubin chips. We'll also have a reference design for TPUs, and essentially you can put any existing chips into orbit. But the current industry seems to be, it seems like it's going to, I don't know, get to maybe around 100 gigawatts a year of AI compute. But that doesn't answer the question of, well, how do you get to a terawatt? That's why you need the terafab.
Always looking a step bigger.
Yeah. Yeah, in order to get to the next order of magnitude, you need a gigantic chip factory. And to give you a sense of scale here, we expect that the terafab is going to be around 100 million square feet, which is 10 times the size of the Tesla Gigafactory, Texas.
And what, aside from just, I'm going to need Starship point to point to get from one end to the other, aside from just the size, what's going to make this unique, different from any other chip building operation on the planet?
Well, I think over time, there's going to be a lot of technology evolution with the terafab, but fundamentally, it's about scale. So even if there were no fundamental technology breakthroughs, you could simply scale the existing chip-making technology with a lot of difficulty to a terawatt of chip output per year. That's, if you look at it just from the logic die standpoint, that's equivalent. That's like having 1 billion chips per year with a kilowatt per reticle. So it's 1 billion full reticle equivalent chips, each doing a kilowatt, and then you're going to need a lot of memory to go with that.
A lot of people today even think orbital data centers were like a decade away.
Yeah, I think we want to try to give people a sense of the time frame. At least the time frame we're aiming for. I mean, people should take this with a grain of salt to some degree, because this is just our best guess. So this is not a promise of what we'll do. This is what we are going to try to do and think we probably can do, which is to get to roughly an annualized rate of 1 gigawatt per year by the end of next year in terms of space AI compute. And then aspirationally, scale that by an order of magnitude per year. So in 2.5 years, hitting an annualized rate of 10 gigawatts a year to space, and 3.5 years, maybe 100 gigawatts. And then depending upon what progress there is in chip making in the rest of the world and with the terafab, going beyond that to scale to a terawatt per year, which is 1,000 gigawatts. Right. Which is, that's twice the current electricity consumption of the United States. No. I think there will be an appetite for that, but we'll see.